corrections, and we're discussing part 2 of question number 7, which is prove that the real part of 1 over z plus 2 minus iota is a constant. Okay, so let's see. Do we have z in polar form, I believe? No, it's not really polar form, but I'm just going to write what z is. It's going to be 1 over z is 2 cos theta plus iota 1 minus 2 sine theta. That's C. And with it, add 2 and minus iota. Okay. Now this fraction becomes 1 over 2 cos theta plus 2, which is the real part. And in the imaginary part, iota and minus iota gets cancelled. And we just have minus 2 sine theta. So this is going to be this fraction shown. Now we have to show that its real part. Okay, I've missed an iota, I believe. There's an iota right here. An iota with it. Okay. So we have to show that its real part is a constant. So we need to write this in x plus iota y form so that we can say that, look, this x is real. And it does not have theta in it, and it does not have an iota in it. And it's real. So, sorry, it's a constant, my bad. It says show that the real part is constant. So you have to show that x is a constant. It is probably will not have a theta term in it. So how do I change it into x plus iota y form? I have to rationalize this by multiplying and dividing it with its conjugate. So 2 cos theta plus 2 sine theta iota and 2 cos theta plus 2 sine theta iota. Okay. So the numerator is 2 cos theta plus 2 sine theta iota, and the denominator is a square minus b square. I'm going to use a square minus b square because it's a minus b times a plus b, which is a square minus b square. So we have a square, which is 2 cos theta plus 2 square minus b square, which is 2 sine theta iota square. Okay. So the numerator is still the same. 2 cos theta plus 2 sine theta iota. And the denominator is, open the bracket, we have 4 cos squared theta plus 2ab. So that's going to be 2 into 2 into 2, 8 cos theta plus 4. And then a negative sign. 2 square is 4. Sine theta square is sine square theta. Iota square is minus 1. So again, the numerator stays the same. 2 cos theta plus 2, which is the real term, and plus 2 sine theta iota, which is the imaginary term, divided by the denominator is 4 cos square theta plus 8 cos theta plus 4 and plus 4 sine square theta. So these can be written together. 4 can be taken common. And when you take 4 common from sine square theta plus cos square theta, this is just 1 and you get 4. So the green part just becomes 4. And then 4 plus 4 becomes 8. So the denominator is 8 plus the denominator is 8 plus 8 cos theta, and the numerator is 2 bracket cos theta plus 1, which is the real part, and plus 2 sine theta I, which is the imaginary part. So now the denominator is, I'm going to split the denominator underneath the real part and the imaginary part separately. So take 8 common and you get cos theta plus 1 here. And we have 2 sine theta upon 8 plus 8 cos theta iota. So we have 1 by 4 as the real part and the imaginary part has theta in it. And we have shown that the real part is a constant. So this is a constant. This is what we were supposed to do. Let me check the working. यही आना चाहिए था या नहीं. We are doing question number 7, part 2. Homework correction. हाँ यही आता. Correct. Okay. Anything else from the homework? Anything from question 6 and 7? Okay, then we move on to question 8. Solve the equation z square plus 2 under root 3 iota z minus 4, giving you answer in x plus iota y, where x and y are real. So let's solve this quadratic equation. Z equals minus p plus minus square root p whole square minus 4ac upon 2a. So we have z equals minus 2 under root 3 iota plus minus, inside the bracket we have 2 square is 4, under root 3 square is just 3, iota square is minus 1. And then we have plus 16 here divided by 2. So we have minus 2 under root 3 iota plus minus square root. That's minus 12 plus 16, that's 4 divided by 2. So we have minus 2 under root 3 iota plus minus 2 upon 2, which is minus under root 3 iota plus minus 1. Yes. These are the two roots. Yes. Both are correct. Answer for part 1. Part 2 is sketch an Argand diagram showing the points representing the roots. Okay. So for part 2, we just have to sketch it on a complex plane where this is imaginary and this is the real value, real axis, and we have plus 1 here, minus 1 here, and minus under root 3 will be somewhere over there. So this is one of the solution, 1 minus under root 3 iota, and this is the other solution, minus 1 minus under root 3 iota. Both are represented on the Argand diagram. Okay. Next part is find the modulus and argument of each root. Okay. So again, one of the root is 1 minus under root 3 iota, and the other root is minus 1 minus under root 3 iota. So the modulus is x square plus y square. So that's 4 and r will be 2. Modulus will be the same for the other. Minus 1 whole square plus minus under root 3 whole square. So that makes 4, square root of which makes 2. Okay, so r is the same for both of them, for both the roots. And now we have to find theta. Theta is tan inverse modulus y over x. Modulus of y is minus under root 3, which we take as under root 3 upon 1. Although it's minus, but just treat it as a positive. That actually gives us the absolute angle. So what is tan inverse under root 3? 60 होता है क्या? Under root 3 in radians. That's pi by 3. Okay. So the first root 1 minus under root 3 iota is here. And you just found this angle. So remember, the theta, the argument in polar form should be between pi and minus pi. So you can't take this as theta because this is greater than pi. Instead, you take this negative theta, which is minus pi by 3. Theta will be minus pi by 3. Okay. For the other one, the absolute angle is still the same. You get theta equals pi by 3 for this one as well. But it's this theta. This is pi by 3. Again, we can't be using this angle because it's greater than pi. Instead, we use this angle, which is minus, because it's a clockwise angle, pi minus pi by 6, which is what? Minus 5 pi by 6. So these are the two arguments. Minus pi minus, it wasn't pi by 6, it was pi by 3. Yeah, मैंने गलत एंगल लिखा हुआ है, इसलिए आंसर नहीं ठीक आ. This is pi by 3. So it would be pi minus pi by 3, which is minus 2 pi by 3. Okay. So we have the modulus of both the roots, which is 2 for both the case, and theta for both of them. One of them is minus pi by 3, and the other one is minus 2 by 3 pi. All right. What do we have to do next? Show that the origin and the points representing the roots are vertices of an equilateral triangle. Okay. So you have to show that the origin and both the roots make an equilateral triangle. This is, this length is 2, remember? Because the argument was 2. Sorry, the modulus was 2. And this one is 2 as well. Okay. Now, what were these points? These were 1, comma under root 3, minus under root 3, and minus 1, comma minus under root 3. So then what is this length? From here till here. It's also 2 units because it's 1 minus minus 1, which is 2. So since all sides equals to 2, hence equilateral. Okay. Next question. Just give me a second. Question 9. The variable complex number z is given by z equals 1 plus cos 2 theta plus iota sine 2 theta, where q takes all the values in the interval minus pi by 2 to pi by 2. Show that the modulus of z is 2 cos theta and the argument of z is theta. Okay, so we have to find the modulus and the argument of z. So z is, the real part of z is 1 plus cos 2 theta plus iota sine 2 theta. So the real part is this, which we call x, and the imaginary part is this, which we call y. So the formula for r is x square plus y square. So 1 plus cos 2 theta square plus sine 2 theta square. So we have r equals square root a square plus 2ab, 2ab. So 2 times 1 times cos 2 theta plus b square cos square 2 theta plus sine square 2 theta. Can anybody tell me what does this simplify to? We know that cos square x plus sine square x equals 1. No matter what is the value of x, this is always true. So this would be equals to 1. So we get square root 2 plus 2 cos 2 theta. Okay. Now you have to show that the modulus is equals to cos theta, not cos 2 theta. So we have to use double angle identity. We know that cos 2 theta can be written as 2 cos squared theta minus 1. And that's what I'm going to do. We have 2 plus 2, 2 cos squared theta minus 1. So 2 and minus 2 gets cancelled. We have square root 4 cos squared theta, which is 2 cos theta. And this is what we were supposed to show, that the argument is equals to 2 cos theta. Sorry, the modulus, not the argument. Argument is the angle. Okay. The next part is show that the argument of z is equals to theta. So we know theta equals tan inverse y upon x. Theta equals tan inverse sine 2 theta over 1 plus cos 2 theta. Again, use double angle identities. We know that sine 2 theta is 2 sine theta cos theta. And cos 2 theta has actually three equal identities. One of them is cos square theta minus sine square theta. Then 2 cos square theta minus 1. And then 1 minus 2 sine square theta. Okay. So let's write sine 2 theta as 2 sine theta cos theta. And the denominator can be written as 1 plus, I'm going to use the cos 1, 2 cos square theta minus 1. This and this gets cancelled. And we have theta equals tan inverse. 2 and 2 also gets cancelled, and cos theta also gets cancelled. So you just have sine theta over cos theta inside. And we know that sine theta over cos theta is tan theta. So we have tan inverse tan theta, and tan theta and tan inverse cancel out, and the answer is just theta. So we have shown that the modulus of the given complex value is theta. The argument. Why do I always mix them up? The argument. The angle, the argument of the complex number is theta. Okay. What's the next part? Prove that the real part 1 over z is a constant. Heather, I think this is the question you had sent me the other day. Heather, मुझे लगता है इस वक्त नफल पड़ रहा है कल के. He is not around.
मैम ये क्वेश्चन नहीं था.
यही था ना जो आपने मुझे भेजा था.
मैम सिमिलर था मगर ऐसा नहीं था.
ये नहीं था. ओके ठीक है.
नो मैम.
ऑलराइट. Okay, so part 2. Prove that real part of 1 over z is a constant. So let's write 1 over z. 1 over z. Because I think I already have it in modulus argument form. Let me just use that. The modulus was z is actually 1 plus cos 2 theta plus iota sine 2 theta. And we already have this in modulus argument form, which is r cos theta plus iota sine theta. And r is 2 cos theta. And cos theta is cos theta. Theta is theta. Wallah, just give me a second. Okay. Acha. So where were we? So the modulus is 2 cos theta and argument is theta. So this should be the complex form. So we have to show that the real part of z is a constant. 1 over z would be z minus 1. And since I already have this in complex form, this would be z minus 1 would be, what do? We give the same power to the r, which is 2 cos theta in this case. And what do we do with the thetas? We multiply the power with the theta. So we get cos minus theta plus iota sine minus theta. Yeah, okay. So z power minus 1 is this. 2 cos theta power minus 1 को मैं लिख रही हूँ 1 upon 2 cos theta. And the rest of it is, remember the identities, cos minus theta is actually the same as cos theta. But sine minus theta is equals to minus sine theta. Here, cos absorbs the minus sign and it does not show after the equals to. And sine sends the minus sign to its left. Okay, so the bracket term is cos theta because cos absorbs the minus sign, and then sine sends the minus sign outside, minus sine theta. So now split your answer into a separate real term and a separate imaginary term. So the real term is cos theta upon 2 cos theta, and the imaginary term is sine theta upon 2 cos theta iota. So we have half minus half tan theta iota, and we were supposed to show that for 1 over z, the real part is a constant, which we have. This is a constant. Let me check the answer for question 9, part 2. इसको आप regular form में भी कर सकते थे. I use polar form because in the previous part they had asked us to change it into polar form. तो De Morgan's theorem लगाना काफी ज़्यादा आसान होता है as compared to complex conjugate लेना, especially ऐसे question में. Or you could have taken complex conjugate of 1 over z and done a ton of algebra and trigonometry, and you would have gotten the answer. ठीक है, उस तरह से भी आंसर आ जाता, but वो काफी लेंदी हो. This is relatively less lengthy. Okay, this was question number 9. Question 10. Let's try to finish this in 10 minutes. The complex number u is defined by this, where a is real, express u in the form of x plus iota y. Okay, that means we have to rationalize it. We have to multiply and divide with its complex conjugate. So times a minus 2 iota divided by a minus 2 iota. So the numerator becomes 5a minus 10 iota, and the denominator is a square minus b square, which is a square. Iota square is also minus, so minus minus becomes plus 4. So it's always better to separately show the real part and the imaginary part. So the real part is coming out to be 5a over a square plus 4, and the imaginary part is coming out to be minus 10 upon a square plus 4 iota with it. So 10 part 1 is correct. Okay, part 2. Hence find the value of A for which argument of U conjugate is 3 pi by 4, where U conjugate denotes the complex conjugate of U. Okay, so I know what is U conjugate. U conjugate would be 5, this is U by the way. It would be 5a over a square plus 4. The real part does not change. However, the imaginary part changes in sign. So we get a plus here and 10 upon a square plus 4 iota. Okay. They're talking about argument of U conjugate. So I know what an argument is. Argument is tan inverse y upon x. So y here is 10 upon a square plus y 4 upon x, which is 5a upon a square plus 4. So this and this gets cancelled. We get a 1 here and 1 here, which can be ignored. So we get tan inverse 10 upon 5a, which is 2 upon it. Tan inverse 2 upon it. And you have the answer for the argument as well. I think that was 3 pi by 4. Yes, so you can equate it to 3 pi by 4 because you're already told what is the argument. Now, you have to make A the subject because we have to find the value of A. So how do we make A the subject? Send tan inverse to the other side, so it will become tan 3 pi by 4, which you can find from your calculator. So what is tan 3 pi by 4? Make sure it's set at radians. Which is -1. So A would be -2. 2 divided by -1 is -2, which is correct. On a sketch of Argand diagram, shade the region whose point represents complex number z, which satisfy both the inequalities. Z is less than 2. Modulus of z, sorry. Modulus of z is less than 2. We know what this means. It's a circle whose center is 0, 0 and whose radius is 2. Okay. So the radius is 2, meaning this would be 2, 2, -2, -2. Okay. Says less than 2, that means the radius is less than 2. That means you'll have to shade the region inside the circle. However, there's also another condition that we have to plot, which is modulus of z is less than modulus of z -2 iota. So whenever we have modulus on both sides of an equals to sign or an inequality sign, that means you have to extract 2 points from the given information and draw their perpendicular bisector. So this point here is 0, 0. And this point here is, you equate this entire thing to 0. So you get z equals 2 plus 2 iota, which is 2, 2. Plot these points. We have 0, 0 here, 2, 2 here. we plot its perpendicular bisector. So you may draw a dotted line here, yeah, solid line here, very light that you must get rid of after a while. And then from the scale, find their center and then plot this line representing the perpendicular bisector. Now this is a very symmetrical graph, so it will be checked okay, whether your line passes through 2 and 2 here. It must. So that's the locus of the second point, second condition. And now we have to do the plotting. It said Z is less than 2. That means you have to shade inside the circle. And here it says modulus of Z is less than the modulus of all of this. So you have to shade that point which is towards the less than sign. So it's this point. So we have to shade 0, 0. So we have to shade this part of the perpendicular bisector, the lower part, the one which has 0, 0 in it. If it was greater than instead, so then we would have shaded the part closer to that gray shadow. All right. Let's end the lesson here and you will be doing the next 2 questions as homework today, 11 and 12. See you tomorrow. Best of luck with the result. मुझे बताना क्या बना. ठीक है, I'll wait for your messages. Take care.
Yes, ma'am.
Allah Hafiz.